Welcome to the Welding Codex. In episode 3, Peter Kinney and I, Garry Pace, welding engineers, are going to dive into Clause 3 of AWS D1.1 Structural Steel Welding Code and have a conversation about pre-qualified welding procedure specifications. AWS D1.1 is different than ASME Section 9 and other welding codes in that AWS D1.1 allows for the use of pre-qualified welding procedure specifications. AWS D1.1 allows for the use of these pre-qualified welding procedure specifications under specific circumstances and conditions in regard to both pre-qualified base materials and filler materials. The Welding Codex is a podcast for those who want to learn more about the technical side of welding. We're going to talk about the philosophy of welding, welding codes, welding defects, and topics of a technical nature. My name is Garry Pace. I'm a welding engineer, and the other two hosts of the program are Peter Kinney and Joel Christie. Both are Ohio State welding engineers. Welcome to the Welding Codex. If you like these podcasts, stop by my website, texasweldingengineering.com, and go to the donation page. Use PayPal, throw me $1 or $2 so that the next time we hit the local Dairy Queen, we can get a large chocolate chip cookie dough blizzard. Also, if you're looking for CWI training at a reasonable price, check out train-eng.com. Joining me today is Peter Kinney. He's a professional engineer, CWI graduate from Ohio State. My name's Garry Pace. I'm a welding engineer. Got my bachelor's degree in welding engineering from Montana School of Mines in Butte, Montana. We're both professional engineers. I'll throw it to you, Pete. Go ahead.
All right, so we're looking at getting into the pre-qualification or pre-qualified WPSs in D1.1 structural welding code. We're going to go through, it is now Clause 5, or you'll catch myself saying Section 5 in D1.1 2020. I believe it was previously Clause 3 in the 2015 code. So there is some new information, but the biggest thing is just a reorg in the code. And so Clause 5 is divided into 8 parts. We got WPS developments, base metals, weld joints, processes, filler metals, preheat interpass, WPS requirements, and post-weld heat treatment. And we're going to try to go through each one of those individually, explain the hows, whys, and booby traps that people fall into.
Okay, and before we go there, we're going to lay a little foundation, a little groundwork. We're going to explain a couple of the acronyms that we're going to throw around in this episode, such as WPS, PQR, and some of the other information, because I think we tend to throw around these acronyms and expect everybody that could be listening to know exactly what we're talking about each and every time. So the first one we're going to talk about is WPSs, which is a welding procedure specification. This is the recipe. This is what the welder needs to follow. This is how many chocolate chips go into each cookie. This is how high you turn the oven to bake the chocolate chip cookies, whatever. So a pre-qualified WPS would be like baking chocolate chip cookies. These things have been baked over and over and over. This is a tried and true recipe. We can weld A36 carbon steel to A36 carbon steel with E7018 at these thicknesses with these preheats. Everything's good. The other type of welding procedure is a qualified welding procedure. This is one where you're using materials that aren't exactly tried and true, or maybe you're doing something that's a little outside the boundaries of the zone of pre-qualified welding procedures. So these we're going to have to qualify. So we're just going to talk about pre-qualified procedures. Not every material can be pre-qualified. So that's where some people get into trouble. Well, why can't I pre-qualify this? Well, your steel's a little too far outside the warm fuzzy boundaries that AWS committees have said this is the bland steels, and you can weld this to this with this to this. Thoughts on that, Pete?
That's exactly right. These recipes have been made tons of times on a lot of materials that are robust, or robust if you follow a handful of mitigating requirements, but are not your 120 KSI, look at me cross-eyed and I'm going to crack kind of materials. And they limit also the processes. Not every welding process is in here. Actually, there's only 4, I believe, that are pre-qualified.
Yeah, what do you got? Stick, flux core, gas metal arc, and submerged arc welding.
I believe that's the only 4 that are pre-qualified.
And we'll talk about gas metal arc short circuiting too. So basically, we're talking about the pre-qualified, but these materials, when Pete's saying they're robust, Pete and I have swam in the deep end of the pool, companies we've worked at where you're qualifying duplex stainless steels, or you're dealing with a titanium or a nickel alloy, or high strength carbon steels that have where you're welding them with a material like 12018, that this stuff is just miserable. You got to preheat it. You got to post weld heat treat it just right. And even then, there's a chance that it could crack on you and you got to go do it over. The D1.1 pre-qualified materials are your basic garden variety carbon steels that you could weld with a coat hanger. And that's an oversimplification, but it's not too far off from a metallurgical and a tensile strength and a mechanical standpoint. I'm sure if somebody listens to this, they're going to freak out and I'll get hate mail, but realistically, that's the level of metallurgy we're talking about.
Correct. They're pretty robust. It's not where we have to really look at doing post-weld heat treatment to drop hardness, or post-weld heat treat bakeouts to make sure our hydrogen gets driven out, or that we really got to look at using extremely low hydrogen materials, or we don't have to worry about hardness constraints by cooling rate from the welding process. Running within the guidelines of pre-qualification has basically already taken care of those issues. Do we want to hit on as we said, it was divided up into 8 parts. The first one is WPS development. As I think, Gary, you said earlier, general WPS requirements. A pre-qualified WPS has to be prepared by whoever's using it, whether it's the manufacturer, the contractor, the fabricator. You're working out of the back of your truck with a welding machine. You got to have a WPS in a written format. It doesn't have to be the format you see you find at the back of the book. It could be your own, but you have to cover all the variables that are required for the given process and materials. You have to have limits and the different variables.
Yeah, you need to address all the variables. This is the thing where I've run across is you have people, well, I welded it, it's a pre-qualified. Well, where's your procedure? Well, I don't need it. It's pre-qualified. No, you have to have it written down. Okay, and here's another thing about writing these pre-qualifieds. We're going to take a little sidebar into Pace's rant on whatever. I'm a person that likes to write specific WPSs. I don't like to have one. I've seen this mistake. I spent years in a cube reviewing people's WPSs, pre-qualified and qualified. You're probably better off to write multiple WPSs and be specific about it. I've seen guys get into trouble when they try and write an all-encompassing weld procedure that covers 3 different processes with 4 different filler metals and 16 different kinds of base metals. You're probably better off to just write one specific, okay, we're welding group 1 to group 1 with 6010. It's pre-qualified. Okay, I've got that procedure. Then I'm going to write another one for group 1 to group 1 with 7018, or maybe group 2 to group 1 with 7018 and 6010. Whatever your combinations are. Writing these things is kind of an art form, and there's some philosophy that goes into it, because people are like, well, I don't want to write. No, you probably want to have a library of these things, and you probably want to have some very specified, not over-encompassing weld procedures that you're trying to explain the universe and give 3 examples. What's your take on this, Pete?
I agree, though I'll throw out this one caveat. if you call out your welding procedures on your shop drawings, you got to be a little careful about it. But I would prefer to have a few welding procedures that call out, let's say, how to make a handful of different size fillet welds, a 3/16 quarter inch, 5/16 3/8 fillet weld. You call out the different parameters. You call out, I mean, you make it in one pass, two passes, or three passes. Your variables are going to be a little different depending on what position you're in. I would rather see that and have, hey, here's our one for making fillet welds, and then here's the WPS for making the groove weld, and we just marry the two together for making, let's say, if you have a groove with a reinforcing fillet. Works real easy. Or you do like one per process. You're right, combining two or three different processes on one, unless it's in the same groove and you have a very specific joint, it becomes very convoluted very quickly. I would rather have a couple, let's say, generic, but generic in there, like this is for fillet welding. It's generic for, let's say, the fillet welds, but not, I got my stick procedure on there. I got my gas metal arc. I got my flex core. Oh, and by the way, we're sub-arcing, and trying to figure out what variables apply to what would be, it becomes very confusing for the operator, and they're just going to go by a little set where the mark is on the machine and never look at the piece of paper.
Here's my thing too with the specific weld procedures. If I've got one that's, I'm trying to think of an example. I've got a welding procedure, let's say, that I'm using for part A, and let's say it's 70/18, and I've only gone up to, let's say, 1/8 inch in filler metal size, and I've got my parameters for that. And then for another situation, let's say I've got another WPS that's pretty close to that one, and it uses the same filler metal size, and it's pretty similar, but I use the wrong. As long as the filler metals are the same and maybe the configuration's different, and I use the wrong WPS, it's you could probably paper your way out of that. And I say that from a QA standpoint because I used the filler metal. We had some things wrong here, but it's pretty damn close. We welded it. Am I making any sense here, Pete?
No, you are. Basically, try not to write one WPS to capture every single thing you do, unless you only do one or two things, because it will be overcomplicated to put in production, and you're more likely to make a mistake. I would make them all similar. I would make the format the same. So it doesn't matter if you're looking at WPS 1 or WPS 100. Preheat's in the same spot, name, the filler metal. You're not going on a Where's Waldo expedition every time the foreman hands out the welding procedure to the welders. And keep them somewhat similar, but you're right. Divide them up where you find logical boundaries of how would I understand this. And the advantage of keeping them with the same format is I prefer to use Excel to make these up. You can make a change in Excel really quickly, and you could take, hey, this is going to be a fillet weld with this kind of groove, or change out the groove symbol to something else if you want to make it applicable to something from one joint to another. Or how you were talking earlier, Gary, about the different Group 1 versus Group 2 materials. You can make a very easy change there, change the filler metal, change your preheats and interpass temperatures, and you probably have a WPS that's ready to go within a short amount of time, but doesn't have confusion associated with having three different filler metals for, let's say, you're a 70 KSI, an 80 KSI, and then the different kind of preheats associated with the stronger materials. So the welder has to figure out, am I using this preheat or that preheat? I think that's the way I would go. And Gary, what are your thoughts on like using Excel, or should I buy one of those fancy programs? How should I go about making welding procedures?
I'm old school. I've never used the programs, and I'm probably going to get hate mail from the program people. Pete and I will be banned. They won't send us Christmas cards. I'm a Word I've used Excel and or Word, but the advantage of using Excel or Word is it makes you dig in the code, and you're going to end up in a meeting across from a guy like me or Pete, and I'm kind of pulling our own chains here, but this is what we've done for the last 2 decades. I spent 3 years in a cube up in the Midwest working for a big engineering firm arguing about codes. And if you're not ready to step in the ring, I'm going to chew you up. And Pete's the same way. You know, you're going to come back with your stuff all marked up in red. So the advantage is if you use Excel or Word, it forces you to get into the code and dig around, and it toughens you up. And you're probably going to get your nose bloodied the first 2 or 3 meetings you go into. You're going to run into somebody that just rips your stuff to shreds, but it's like fighting the bully on the way to school every day in the 5th grade. Eventually you're going to get tough and you're going to learn how to whoop some ass. So
That's right.
that's kind of my take. I'm not real big on the software. I'm going to digress here real quick, Pete. I worked for a company out on the West Coast, and we had it was a foundry on the West Coast, and we probably had 100 WPSs for welding 7018 on carbon steel castings. But a lot of these, most of the WPSs went back to the same procedure qualification. But we'd have customers come in and say, well, I don't like the preheat on this. Add 25 degrees to that preheat. Or do this on the cleaning. We don't like those we want a special kind of wheel, grinding wheel we want, or we want this done. I don't like that wording. You're not really changing the WPS per se. You're just addressing a couple of non-essential variables for that customer. So then if you did use the wrong WPS, this is what I'm talking about papering your way out of it. Let's say I used the Acme WPS to weld on Fred's barbecue stuff, and Fred's barbecue QA people find out that I used the wrong WPS. Well, I can go back and say, dude, yeah, we screwed up, but here's what we did different. This is the only difference in these WPSs. We use the same filler metal. We do everything except this one little thing. I can write QA paperwork to get myself out of that one. I can deal with that. We can write an NCR and come out of that one. But if you've got ugly WPSs with just way too much information, you might be cutting out welds. That's where I was going with what I said before. Where are you at, Pete, with back to your software question, or the Excel or Word? Or
So I prefer Excel. That's because I could do where it's some simple if-then statements or some multiplication. So I'm an Excel favorite. I have used some of the bigger programs out there. There's advantages. The big disadvantage is you don't learn to code. It's, well, the program said it was good, so it must be good. You never understand some of the nuances or why it would be good or why it would not be good. I think you do lose that. Where it is helpful, though, is it's easy to change a lot of things. You just change a couple of variables or add some information, save it with a new number. A lot of them have added on like welder tracking for continuity or when their certification goes out. So there are good things, but I think where everyone should start out is by doing it, well, I'll say like the pen and paper method, Excel, Word. Learn that way, so you learn the code first. Then if you want to graduate up to using a program, you know how the program works, and you know when you're like, you know what, that program is saying it's okay, but I don't think it is for whatever reason. Or if you have to override it, like let's say
you know how the code works.
Exactly. You know how the code works, and you know when to call BS on it. Or even if, let's say, because the engineer, as we talked about in our last episode, can change things, and maybe whatever they change, the program, because it doesn't know that the engineer changed it and it would never know, you have to override what the program says, and you'll be fluent in knowing I could change this and I'm not worried about it because I understand the ramifications of this change. So if you go to the programs, learn to code first. I guess
Well,
that's my stance.
well, and this gets back to the welding world, the welding approval and submittal world. This is my version of how the welding world works. About half the time, you end up going into a meeting and it ends up being a fight. If you don't know the person, it's going to be a fight until you figure out who's who. A lot of times it's networking. There's guys I worked with years ago, or like Pete. If Pete's reviewing my documents, I can just send him, "Hey Pete, I'm going to send this over. Tell me what you need on it. Good to go." But if it's the first time we've dealt with each other, or there's an acrimonious relationship with the guy, a lot of times this stuff ends up being a fight. And you got to know the code when you go into these meetings. I've been in meetings where I'm trying not to say be too unprofessional, but where it's like things got very heated. And I thought if we'd have been in a schoolyard, we'd have been going across the street to slug it out afterwards. I mean, there have been some meetings that have just gotten less than
A little
professional. So you got to know
sideways.
the code.
Yeah, you got to know the code, and you have to know the specs associated with it. But you really got to know the code on where things are at and the changes of things, where things become unprequalified and they put you in the realm of qualification to where all of a sudden you're like, oh, I didn't know I need to qualify that. But
There's some nuances that will get you there. All right,
so
let's reel it back again. We're getting off on the weeds. I'll take the hit on that one.
all right, no
So
problems. Base metals. We're on
we're
base metals now. Okay, so basically, now it is table three. Is only the materials in table three or 5.3 can be used, are pre-qualified. So if you're welding on some cast iron, you're like, oh, I thought this was pre-qualified. Well, let's find it in that list. Oh no, I can't find it in that list. That means it's not pre-qualified. There's a lot of materials in there, and they're separated into groups. You probably heard us throw them out there: Group One, Group Two, Group Three, all the way up to Group Four. And the easiest way to look at them is Group One is your A36, your A553, ASTM's A553. These are your like 50 KSI and less materials for yield, and your tensils are normally somewhere, 50 to 60 minimum. We're not talking about real strong materials here. Very ductile materials in play. And as you go up to, let's say, a group 2, well, some of those still might be a little low, but all of a sudden now you're talking about 40 and above for the majority of your group 2s. So what's happening? You're getting stronger. Your tensils now may be 65 KSI and higher. So we're increasing in our overall strength. Group 3, now our minimums are more in the 60s for a yield strength, and our tensils are 70, 75 minimum. And then, as it makes sense, Group 4, we're hitting a minimum tensile of 70, and our minimum yield is 70, and our tensile range is 85 and up. So it's a lot stronger.
all right. So to come at it from a different direction, then maybe put some context into what Pete was saying is, okay, Group One is the shallow end of the pool. You really got to really work to mess this material up if you're welding it. And I say that I'm probably going to get hate mail again, but for the most part, you can get some 70-18 or 60-10, and if you are relatively competent at welding, you should be able to weld this material and not have too much difficulty. And I say this because, like Pete and I were talking, you have, if you're welding some of these weird materials in power plants that you got to do the hydrogen bakeouts and whatnot, these are not those materials. These are hit it with a little bit of preheat, weld it together with some low hydrogen material or some one of the pre-approved welding materials, and you're not going to have too many issues.
Correct.
90% of the population should be able to get this. Well, then you go up to Group 2. It's more or less Group 1, but it's just a little more difficult. There's some things that might go wrong here. It's a little stronger material, but for the most part, you're still in the shallow end of the pool. You're not really weird preheats and whatnot. Well, then you get to group 3 materials, and with the group 3 materials, it's a little more difficult to weld. The weldability isn't as great, and like Pete said, you have a lot. Your tensile strengths are starting to climb up here, and by the time you get to group 4, you only got 3 or 4 materials in there that can be pre-qualified.
Yeah, there's only 3 in group 4. The other thing I wanted to point out, in one of the differences between group 1 and group 2, you may see the same materials in both, but what you will see is in group 2, they become thicker. And that happens a little bit in group 3, but not nearly as much as it is from group 1 and 2. And the reason in the change in thickness is the thicker you make a material, normally the more, I'll say, trash that you'll start to get, especially center line of the material. It won't be as clean. The base material indications will become larger, or you like a lot of, one of the big ones is magnesium sulfide stringers. You'll see a lot of those in thick material. In thin material, let's say like inch and thinner, they'll be, much more broken up, very fine because of the rolling process. Also, the steel mills, what they will do is, if they know the end result is a 4-inch thick plate, the chemistry is a little different than in the end result of a 1-inch thick plate. So with the higher chemistry, or let's say a little richer, a little more carbon, a little more this, a little more that, the weldability becomes more difficult.
But it gets back to, if your material isn't on this list, you can't use it. I just answered a question for a guy out of Malaysia on a AWS board, and he was asking about some Chinese material. Well, the local suppliers say it's the equivalent to ASTM A blah 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 blah, and I'm like, nope. It ain't. It's not that. You need to qualify that stuff, and you probably need to qualify it for each heat that you use, because that steel doesn't have any. It basically has 2 chemical requirements. It's got to have less than 0.05 sulfur and 0.05 phosphorus. Other than that, it's wide open chemistry. So American materials, ASTM materials, are a lot tighter than the materials that are produced, like some of the Chinese materials, their grades. So this is something you'll run across. So if it's not on there verbatim, you can't use it. And this list will change. So you might have a material that was listed on the 2004 version of the code, and it's not on there now. So you work to the latest version of the code.
Yeah, you bring up a good point, and I was actually in a committee meeting about that. I fought to keep in old materials, mainly from the standpoint. So what the code issue is ASTM ABCDY XYZ was obsolete. It was no longer made, and that was the argument for deleting it. And my argument for keeping it was, well, I understand there's not going to be any new stuff made of it, but what about the old stuff in the world that already exists? Now, if I go to weld on this old structure or old part that had this ASTM material in it, it's not pre-qualified. I have to test it, and I can't find this material anymore. It's no longer made. So you got to start jumping through some hoops unnecessarily. Unfortunately, I was outvoted, and they deleted it, but it wasn't a deletion because of a problem like, hey, we had this material was pre-qualified for the last 10 years. All of a sudden, we've came across all these problems with it. Let's remove it because of that. That's a different story. This one was deletion just because it was the specification was made obsolete by ASTM. So we got to watch out for that. That's something to worry about. And I believe, to build on what Garry was saying, there are specs, even ASTM standards, that are chemistry only standards. They are not They have no tensile or yield values, elongation, because they could drastically vary depending on heat treatment. I do not believe any of these are those kind of specs. I believe all of these, if you go to ASTM A10, 18, and you look at the different grades, you will find mechanical straights for all of those. I don't believe any of these are chemistry-only specs. I have not looked at every single one of them, but I believe all of them are. They have full mechanicals to go along with them and chemistry ranges that they have to be within.
All right, that's a good break point for our conversation today and this podcast. That's about 30 minutes of high quality conversation in regards to AWS D1.1 and the pre-qualification of welding procedures. We're going to pick up in our next episode right where this one takes off. The next one, we're going to start talking about pre-qualified weld procedure specification weld joints and the weld joints that are acceptable for use with pre-qualified welding procedures. Thanks for listening. Hope this podcast was worth listening to. We're going to have more content coming out. Also, if you want to shoot me an email, gpacex@gmail.com. Give me some ideas, or maybe there's some questions that you'd like me and Pete or me and Joel to answer in regards to welding codes, filler material, or any other material joining question that you might think we have a shot in hell of answering. Anyways, thanks for listening. Take care. Peace out. If you like these podcasts, stop by my website, texasweldingengineering.com, and go to the donation page. Use PayPal. Throw me $1 or $2 so that the next time we hit the local Dairy Queen, we can get a large chocolate chip cookie dough blizzard. Also, if you're looking for CWI training at a reasonable price, check out train-eng.com. Also, if you're not familiar with my YouTube channel, there's a bunch of YouTube videos on there. If you just do a Google search under Garry, Pace, Welding, ASME, or AWS D1.1, there's a bunch of videos on there. Check those out too if you're interested.